All right, in this next part of the lesson, we are going to discuss imaginary numbers. Now, just like this monster from Monsters, Inc., what I want you to remember when we deal with imaginary numbers at the very end, you should only ever have one I. So what that means is when it's fully simplified, you should never have I squared, I to the third, whatever. You should only ever have one I. All right, so before we get started, I just want you to take a minute in your notes and turn to Unit 3, Day 6, and go ahead and try these questions at the top just to make sure you understand them. So go ahead and hit pause, try this, find the discriminant, and then solve for the x-intercepts. All right, so hopefully you had a chance to solve this. Number one, hopefully you should notice right here that you have two x-intercepts, okay? So that's gonna end up telling me that I have two real solutions, and we just have to decide if they're rational or irrational. But let's do that using the discriminant. So remember your discriminant is b squared minus 4ac. So in this case, it's gonna be 3 squared minus 4 times 1 times negative 1, which is going to give me a positive 13, okay? So that discriminant of a positive 13, if I put that underneath the radical, because in my quadratic formula, it's under the radical, that's actually going to tell me that I have two real solutions that are irrational. And that's because, remember, this is not a perfect square. So let's find the x-intercepts. This doesn't factor, so since it doesn't factor, we're going to have to use the quadratic formula. So x equals negative b. Now here's the nice part. You don't have to do the b squared minus 4ac because we already did it right here. We already know that that's 13 all over 2a, and in this case, a is equal to 1, so that's just 2. All right, so here we can't simplify the square root of 13, so this is my solution, and then my x-intercepts are negative 3 plus or minus the square root of 13 all over 2 comma 0. So you could figure out what those decimals are if you wanted to. All right, so let's take a look at this one right here. We notice we have one x-intercept. Okay, so that's actually going to tell me that I have one solution. Okay, and hopefully you recognize that this should mean your discriminant 0. So to find my discriminant, it's b squared minus 4ac. So b squared, and remember, negative 6 squared is really positive, minus 4 times negative 1 times negative 9, okay? And that's going to give me 0 because this is 36, and you have 3 negatives here, so that makes that a negative, minus 36 gives me 0, okay? Now, if you notice, you have your x-intercepts, we can actually already figure out right here that this is negative 3 comma 0. If you wanted to solve for this, you could either factor or use the quadratic formula. Either are going to work in this case. Okay, so we're going to take a look at complex numbers. Now, we said before, you can't ever have a negative under the radical. Well, what this is going to do here is this is going to get rid of the negative under the radical. So what we're going to say here is I is the same thing as the square root of negative 1. So anytime we have a square root of negative 1, we're going to pop it outside of the radical and make it an I value. So what I'm going to do with this first one is first I'm going to rewrite this as a multiplication of the square root of negative 1 and 25. So I could rewrite this as the square root of negative 1 times the square root of 25. Well, what you're going to do here is say, okay, the square root of negative 1, I now know is going to be I. The square root of 25 is going to be 5, so I can write this as 5i. Okay, now let's take a look at this one. Let's do the same thing here. So let's pop that negative outside the radical. Okay, so we have negative 1. Okay, times positive 6. And since these are both under the radical, that's why you can multiply them. Okay, so negative 1 times your square root of 6. This negative 1 becomes the I. Can't do anything with the square root of 6. So this becomes I times the square root of 6. And I often put the I in front here just to make sure it doesn't look like it's under the radical because it's not under the radical. Okay, so this one right here. Okay, you have the square root of negative 1 times the square root of 10. I'm going to take the square root of negative 1, that's I. I can't simplify the square root of 10. Okay, so this is going to be I rad 10. All right, why don't you take a second and try that one on your own. All right, hopefully if you need to pause it for some more time, go for it. So this is the square root of -1 times the square root of 72. So this is going to become your I. Okay, and you can simplify 72. So 72 breaks down into 36 times 2. Okay, so I know that the square root of 36 is 6. That pops outside the radical. 2 you can't take the square root of, so that stays 2, and then the I is out front. But I might write this one 6I rad 2. Okay, all right, so if you have any questions about this, let me know. All right, so the next thing we're going to do is we're going to figure out, because in the end, you're only allowed to have one I. You cannot have I squared, I to the third, I to the fourth, or anything like that. So what you're going to do here is we want to figure out, so what happens if you do end up with I squared? Well, I squared is the same thing as -1 times the square root of -1, because I squared is the same thing as I times I. All right, so I'm going to replace I with square root of -1, I is the square root of -1. Now, remember what a radical means. Whatever you see twice under the radical pops out. For example, the square root of 25 is the square root of 5 times the square root of 5. So therefore, the answer is 5. That's what you saw twice. So I squared is the same thing as -1. So anytime you see I squared, you're going to replace it with -1. Now, I to the third, think of that as the square root of -1 times the square root of -1 times the square root of -1. Now here we can say square root of -1 times the square root of -1 is just -1. And then I'm left with this right here, which the square root of -1 is just I. Okay, so in this case, it's just going to be -I. Okay, and then let's check out the last one, which is I to the fourth. So that's the square root of -1, square root of -1, square root of -1, square root of -1, because there's 4 of them. Now remember, square root of -1 times the square root of -1 is -1. Okay, here, square root of -1, square root of -1 is -1, and that answer is just 1. Okay, all right, so what I had a student do, I'll show you this in 1 second, what I had a student do to kind of remember this. I will draw it on the next slide. Okay, so standard form for a complex number is a plus bi, where a is the real portion and b is the imaginary portion. Now, all that means is if I have 5 plus 3i, this is your real portion, this is your imaginary portion, okay? So then what you would say is, like, I could even write, for example, I could say that 3i is in standard form because that's the same thing as saying 0 plus 3i. There's your real portion, there's your imaginary portion. So just some things with I. Number 1, you never, ever, ever leave a negative underneath a radical, ever. So now we're going to pop that I out front. We're always going to simplify I so that it doesn't have an exponent of higher than 1. Okay, so you, like I said, you can only see one I. All right, so I just want to show you something for a second. Okay, so you can have an I, okay, or this is kind of like a circle. If I say I squared, it's the same thing as -1. Okay, I to the third is the same thing as -I. And I to the fourth is the same thing as 1. So if you just kind of want to think of that as we're going through this, you can. You're kind of like, and now think about your goal here. Your goal is to simplify it as much as possible so that you only have one I. And if you're not sure what I'm talking about, just hang on a second. Okay, so I'm going to do 1 or 2 of these, and then I kind of want you to try some on your own. So let's take a look at number 2 first, okay? So this says I to the 41. Now, if you take a look right here, I to the fourth is the same thing as 1. So I could rewrite this exponent right here so it's all in groups of 4. So think about this. So I could write I to the fourth, I to the fourth, I to the fourth. I could keep going, I could keep going, I could keep going. How many times would I write that? Well, I would write I to the fourth a total of 10 times. Okay, so I to the 4th times 10, that's going to give me I to the 40th, and I need one more I to make it 41. Now, remember, I to the 4th is the same thing as 1. Okay, so 1 to the 10th is just 1. Then you just have an I left over. Okay, now the other thing that you could do is you can take your exponent and say, what is 41 divided by 4? And find the remainder. 4 goes into 41 10 times with a remainder of 1. What that remainder of 1 is going to tell you is that I squared, I to the 3rd, or I to the 4th. Remainder of 1 would say I have one I left over. Okay, so that's one way to do that. All right, so let's take a look at this next one. I to the 66, all right? So I to the 66, if I kind of want to do that same thing, let's think about it in groups of 4. Okay, if I take 66 divided by 4, what is my remainder? Well, how many times is 4 going to 66? And you might have to do the long division here, but that answer is 16.5, or 16 with a remainder of 2, because 16 times 4 is 64. To get from 64 to 66, I have to add 2. Okay, so whatever my remainder is what I'm going to have. Okay, so in this case, it's going to be I squared. Well, what did we say that I squared was the same thing as? We said that's the same thing as -1, because you can never have more than one I. Okay, the other way you can do this is using exponents. So let's just say I said I to the 4th, okay, and that would be times 16 to the 16th power, because remember you multiply exponents. That's going to give me 64, and then I need an I squared left over. Well, I to the 4th is always going to be 1, so that basically cancels out, and I'm left with I squared, which is the same thing as -1. Why don't you try I to the 75? Take a second, pause it, and try it. Okay, so if you use the method of dividing, so 75 divided by 4 is going to give you 18 with a remainder of 3. Okay, so you have 18 remainder 3 here. So that remainder of 3 is going to tell us that I have I to the 3rd. Well, what is I to the 3rd the same thing as? That's the same thing as -I. Okay, you could also, like I said, do this using exponents. If you wanted to do this using exponents, you could say I to the 4th. Okay, raise that to the 18th power, because 18 times 4 is going to give you 72. And you have I to the 3rd left over. So all of these would add together to get you 75. All right, so let's try number 4. Now number 4, since we have a squared here, what this means is we want to do -3i times -3i. Now let's multiply this out. -3 times -3 is +9. I times I is I squared. Now I said you can never have more than one I. So here, I squared, remember, is the same thing as -1. Okay, so if we look over here, I squared is the same thing as -1. So we're going to say 9 times -1, which is just -9. All right, and go ahead, if you want to try number 5, pause it, go ahead and see how you do. Okay, so in this case, you should have had the square root of -1 times the square root of 17, and this became 17i. All right, go ahead, pause the recording and try number 4. Okay, so for this one, I to the 12th, okay, that you can divide by 4. So 12 divided by 4 is 3, that's a whole number. The remainder is 0, so I to the 12th is just the same thing as 1. I to the 14th, when you divide that by 4, you get a remainder of 2, so that's going to be I squared. I to the 20th, you divide that by 4, that gives you 5, so that's 1. And I to the 6th, when you divide that by 4, that's 1 with a remainder of 2, so that's I squared. So this becomes 1 minus 1 plus 1 minus, and then I squared is the same as -1, so your final